Today we're going to talk about solving rational equations, and you may or may not remember solving proportions back maybe starting in 8th grade. Here's the classic flagpole problem. So you can read that to yourself. Here's a diagram that illustrates it. So what we're going to do is just set up a proportion. So one thing that you could do is height over shadow equals height over shadow. Always helps to draw a diagram. So the height for the friend is 5 and they cast a 2 feet shadow. And the height on the flagpole we need to find, and it casts a 10-foot shadow. And so this is really like similar triangles. So this would be a right triangle and this would be a right triangle. And so we're just going to substitute in the values. So we would have 5 over 2 is equal to x over 10, and then we're just going to cross multiply. So we have 2 times x is equal to 5 times 10. Solve for x. So x in this case is 25 feet. So the flagpole would be 25 feet tall. So when we have a proportion, one way to solve it is just by cross multiplying. But I would say only cross multiply if you have a proportion. So let me remind you what proportion is. It's 1 fraction equal to 1 fraction. You'll see another example of rational equations in just a bit, but for now, all we're going to do is cross multiply. So I have x times x plus 2, not a bad idea to write that out, put it in parentheses, is equal to 1 times 3, which is 3. And the reason you should put in parentheses is because now we're going to go ahead and distribute this x. So I have x squared plus 2x equals 3. So we're going to solve this. It is an equation. It has an equal sign. The directions are to solve. And so to solve this, I'm going to go ahead and subtract 3 from both sides. X squared plus 2x minus 3 equals 0. All of you should know how to factor this by now, so I'm not going to spend time on talking you through factoring. The factors would be x plus 3 times x minus 1. And I'm going to go ahead and set each factor equal to 0. And so we get x equals negative 3 and x equals 1. And that's our solution. I'm going to put it in a solution set because this is definitely, both of these values are part of the solution. I'm going to talk a little bit in class about when you should check or why you should check to make sure that they are in fact solutions. So we're going to be getting into that in the examples we talk about in class. But for now, we're just going to try to get this procedure down. So this is a different type of rational equation where it's not just a fraction equal to another fraction. We actually have 2 fractions being added together on this side and 1 fraction on the other side. And so here's the procedure. We're going to multiply every single term by the least common denominator. And so I need to examine the 3 denominators here. As you can see, I have 28, z plus 2, and 4. So 4 goes into 28. That's a good thing. And so I know that I need to multiply this by 7. Hold on just a second. I'm going to be multiplying every single term by the least common denominator. And so I would have to multiply this by 7 to get the 28. But I also have the z plus 2 here. So it looks like our least common denominator is going to be 28 times z plus 2. Like I said, the 4 goes into the 28, but I need the z plus 2 over here, and I also need the 7 and z plus 2 over here. So I'm going to multiply every single term by this, and hopefully you'll see what happens in a second. So I'm going to write all of this out. So I'm going to rewrite this every single time. Okay, and I'm multiplying it by 3 over z plus 2. And I'm going to multiply this last term by the same thing. So because I'm multiplying every single term by the same thing, the equation remains equivalent, but you'll see what happens now. So if it helps, I would put this, what you're multiplying it by, over 1. Because now we can kind of simplify each term by dividing out the common factors. So here the 28 divides out with the 28, and I'm left with z plus 2 times 9. Over here, the z plus 2 divides out with the z plus 2, and I'm left with 28 times 3. Bring down the equal sign. And over here, the 4 divides out with the 28, and I'm left with a 7 times z plus 2 times 3. And so I'm just, in this step, I'm just going to multiply the 7 and the 3. I have 21 times z plus 2. And so hopefully you can see that by multiplying every single term by the least common denominator, we're actually eliminating the denominators, which is a lot easier to work with. So I'm just going to simplify what we have now. And I'm going to distribute the 9 over here. So I have 9z plus 18 plus 84 equals, I'm going to distribute the 21 over here. And I'm going to go ahead and combine like terms. Let's see, what does that give me? 102. And solve for z. So I guess the hardest part of these types of problems is just coming up with the least common denominator. After that, after we practice a little bit, hopefully this isn't too bad. It's a pretty straightforward procedure. Subtract 42 from both sides. I'm going to run out of room. So I have 60 equals 12z. And divide both sides by 12. So z is 5. Now, like I said, we're going to be talking about checking your answers and why that's a good thing with rational equations. But that's the procedure. Hopefully you took enough time to write all of that down. If not, pause it. And here are 2 of these examples for you to try. One of them is just cross multiplying, and the second one is to find a least common denominator and follow that procedure. And we will talk about all of this in class tomorrow.